Okay, so this week we're going to start on so-called propositional logic. I already talked about propositions last lecture. Now we're diving into propositional or symbolic logic. You'll also hear this just called sometimes full stop formal logic, right? Well, it's a part of formal logic. It's not the whole thing. Now, look, before we do this, let's take a little bit of time and review where we are so far, right? We've been talking about the form of arguments, right? And here is a valid argument. We've used pretty similar examples before. This one's just a little toy example, right? Either Colonel Mustard or Reverend Green committed the murder. Reverend Green didn't commit the murder, so Colonel Mustard did it, right? Now, if we want to get rid of all the words, we've done this before, we've done this a lot. We just want to look at the form. Either A or B, not A, so B. Here's another one. Bob and Sarah did not both go to the party. Sarah went to the party, so Bob did not. I don't know if we've talked about this form yet, but not rocket science that this is valid, right? Not A and B. It is not true that both A and B are true. A, so not B. So what's the point of propositional logic? The point of propositional logic, two main things. One, you want to focus just on the form of the argument. Well, actually, three main things. And two, you want incredibly precise, almost mathematical or mechanical rules. In fact, you could say they are mathematical or mechanical rules to settle whether these claims are valid or not. And finally, you want your statements to be absolutely clear. You want them to be precise. You want it to be really clear what it means. And partially, this is just taking a step further than what we've already done, right? We've already been doing this. When we put it in this form, either A or B, not A, so B, not A and B, or the all A, F or G, things like that. We've already been trying to just bring out the form, the logical form. Propositional logic takes that a step further. And so the first step in putting a sentence into propositional logic, into using it to evaluate the truth of arguments, is just to do what we've already done, replace all the propositions with letters. But notice, these sentences, even when they're put in sort of very schematic form, when we replace everything with letters, we still have a few words in English, right? Either or, not so on and so forth, right? Propositional logic goes a step further. It replaces all of this stuff, the ors and ands and nots. And even if you get far enough, the alls and sums, I'm not sure we'll get that far. But it does all of that and replaces those with connectives. It replaces them with little symbols that are supposed to show how the propositions relate to each other. And we, in the next few lectures, will talk about three different ones. All right, so our three symbols that we're going to use, or we're going to start talking about this week, there's one more, or actually two more we'll talk about, the conditional ones in a few weeks. We'll just spend a little time with these, though. And you have either this little upside down caret or the ampersand symbol. Smith uses the little upside down wedge, the little caret kind of thing. I don't. You will see a lot of logic books use this. If you're doing these freehand, it's a lot easier to write this than it is the ampersand. I'm just using the ampersand because I'm typing these, and it's a lot easier to find the ampersand, the second we'll figure, than it is the wedge. If you are writing these out freehand, feel free to use the wedge, but I will mostly use the ampersand. They mean the same thing. I'm just going to use whatever's easiest to find on a keyboard, though. Second symbol, or equals V. Smith and I are using the same one there. And finally, not or it is not true that. He uses the little sideways L. I use, and you'll see a lot of logic books use this too, a very similar symbol, this tilde symbol. Also, again, just for the reason that it's easier to find on a keyboard. If you write these out long, if you type these, I'm going to guess the tilde will be easier to find. If you write these longhand, it might be a little easier to do the second one. Use whichever one you want. And also, especially if you're going to do future logic classes, though, with the and the not, do be able to recognize either of these if you see them. It's like math, right? It's like math in a lot of ways, but it's like math in that, you can represent multiplication a lot of different ways, right? You can use the little star symbol, you can use an X, you can just put two letters or numbers next to each other inside parentheses. Logic is the same way. Different people will represent these symbols in different ways. These are the most common. Learn them. I will use the ones I use just because they're easy to find on a keyboard. But for the and, you can use the caret or you can use the little sideways L. I don't care. They're probably easy if you're writing them freehand. And also, especially if you're doing future logic classes, be able to recognize these in the same way that you might recognize, a star for multiplication. All right. So let's get into this and actually start using these. And I'll focus mostly on and in this lecture. So, one we've already looked at, Jimmy Carter was president and governor of Florida. What are our two propositions here? Jimmy Carter was president. Jimmy Carter was governor of Georgia. How are they linked up together? Well, there's an and, so we use our little ampersand friend, right? Smith is very, very, very insistent on using PQRS. He has his very fussy logician reasons. I don't care. The level of how much he cares about this is far rivaled and I think exceeded by the extent to which I do not care, right? And I don't think it's important for you to care either. You can use whatever letters you want to represent whatever sentences you want. Just tell me which ones you're using and be consistent. But just to make Mr. Smith happy to start out with, we will use P and Q, right? His little fussy logician English heart sing, right? So P equals Jimmy Carter was president of the U.S. Q equals Jimmy Carter was governor of Georgia. Jimmy Carter was president of the U.S. and governor of Georgia. P ampersand Q. P and Q. Now, you'll hear people talk about truth conditions. And Smith waits a while to introduce this, and I don't really know why. Because I actually think to understand what we're up to with propositional logic and connectives, it's kind of important to talk about this as soon as possible. Now, truth conditions are just a fancy way of saying when is this statement, be it a letter or an overall formula, true or false. Well, when is P and Q true? It's true when both whatever statement P represents is true and whatever statement Q represents is true as well. In every other single case, it is false, right? What about this statement? Jimmy Carter was president of the U.S. and governor of Florida. Two propositions, president of the U.S., governor of Florida, U and F, right? What is the truth value of U and F? Well, it's false, right? Why? Because to be true, both U and F would have to be true, and F, as I have told you, is false. He was not governor of Florida. He was governor of Georgia. Now look, in the real world, it might be, not every statement is going to be as simple as, this. It might be unclear whether it was true or false. Again, some propositions we don't know. We don't really need to tackle that, though, because remember, logic is not about, especially deductive logic, is not about, well, do we agree with this statement or not? Is it true or not? We just need to know, what follows from the statement. So, well, we just pretend that it is always clear that, it is true or false, and what's going to happen if it is, right? We don't need to get into the messy world, real world of vagueness to talk about validity. So let's talk about truth tables. And a truth table tells us when a formula using a connective, one of our symbols, is true and when it's false. It lays out every possible case. Well, I'll talk a bit more in a few weeks how to construct these. I'll say a little bit today, but you don't really need to know this yet. But look, what's our truth table for and? And when we make a truth table, we just abbreviate the true as T and the F as false. Now, one thing you guys might notice already is that this looks a lot like math. Well, another thing you could notice is what if we replaced our T with a 1 and our F with a 0, right? Hold that thought. I mean, if you're into computers or any kind of electrical engineering, you might already start to be, having some kind of brain waves here, right? Hold that thought, though. But, truth table for and, right? A, B. When A and B are both true, the A and B statement comes out true. Every other possible combination, there's 3 others, and in every single possible combination, it's false. And that fits our normal way we think about ands, right? And so, one thing to keep in mind is in one very real sense, a truth table defines what a formula means. For the purposes of logic, the formula, basically what it means, can be reduced to when is it true, when is it false. And in light of this, I think you can see, or I hope you can, that this ampersand symbol also captures the meaning of but. If you don't see that, think about these statements. If I say he's only 7 years old, but he's a chess grandmaster, when is that statement true? What are, in the jargon we've been using, what are its truth conditions? What has to be true for the statement, he's only 7 years old, but he's a chess grandmaster, to be true? What has to be true? What about he studied hard but only made a C? Think about this. 2 propositions here. He's only 7 years old. He's a chess grandmaster. When would this statement be false? Well, it'd be false if he were 8, right? Or he were 15. It would be false also if it turns out that he's a really good player but not a grandmaster, right? Well, if we look at the truth conditions, when it's true, when it's false, they're exactly the same as if we used an and. So the ampersand works. Our other one, he studied hard. 2 propositions here equals S. He only made a C equals C, right? Well, when is this statement true? It's true when he both studied hard and, in fact, made a C, right? If we find out that, well, no, he didn't, actually, he didn't crack the book for more than 10 minutes a week, we would say the statement's false. If it turns out that he actually made a B, we'd say the statement's false. If you think about it, statements like but are not really, the difference with and is not what they're saying about the world, it's just an expressing maybe our attitude about it, right? If I say and, I'm not surprised or whatever that the two things go together. When I say but, I'm probably surprised. I might even be a bit regretful. It might be something that makes me sad, like here. But that's about me and how I feel about it. That's not what the sentence literally says about the world, about what happened, right? Me and my feelings don't go into this, my attitude toward things. It's just what makes this statement about the world, about what it's about, true or false. For those purposes, and but mean the same thing. Now, one thing to note is that when you put something in the form of symbolic logic, you lose information. It is not always unimportant that I'm surprised about something or I have a certain attitude. I'm conveying information to you when I say that, and it might be important information. You lose that when you put the statement in the form of symbolic logic. Hopefully you gain something in the way of precision, and maybe in seeing the logical form too, hopefully, but you lose some information. There is a cost. So just keep that in mind. And, I will say, this is just a general sort of feature of models of things generally, right? Symbolic logic is supposed to model our reasoning and do it very precisely. In any sort of simplified model, you're going to lose things. The hope is just that you keep the important stuff. We'll see how well symbolic logic does this. Maybe in some cases not perfectly. But those will be issues for future weeks.